I'm Rachel Rudolph, the Extension Vegetable Specialist for the University of Kentucky, and today we're going to cover soil sampling and testing for high tunnel tomato production. Soil fertility is the capacity of the soil to receive, store, and pass on energy to support plant growth. It is the overall nutrient status of the soil and the ability of the soil to provide nutrients to plants. There are three components to soil fertility: chemical, which would be the nutrients like nitrogen, phosphorus, potassium, soil pH. There's biological, which would be the microorganisms contained in the soil or even earthworms. And then the physical would be parent rock, compaction, aggregation, the minerals contained in the soil. There are certain nutrient requirements for all plants. There are macronutrients and micronutrients. The micronutrients are not less important than the macronutrients. They are just required in smaller quantities compared to macronutrients. So you often hear a lot about nitrogen, phosphorus, potassium, and quite a bit still about calcium, magnesium, and sulfur, but you may not hear so much about zinc or boron or manganese, but they are important and essential for plant growth. The crop nutritional requirements are the same regardless of whether the system is conventional or organic. The source of the nutrients supplied will change depending on the production system. So for example, a tomato that's grown organically would need nitrogen from certain sources, natural sources, whereas a tomato produced conventionally could use those natural sources, but it would also be able to use synthetic nitrogen. Soil fertility in high tunnels is quite a bit different from open field soil fertility. Many people do not notice those distinct differences between those two production systems for the first couple of years growing in a high tunnel. But as the high tunnel stays covered and is continually being cultivated, growers begin to notice vastly different aspects to growing in a high tunnel. One of the things to keep in mind is that essentially a high tunnel becomes an irrigated desert. The only irrigation, the only water that is supplied in the high tunnel is that from irrigation, from what the grower supplies it. That leads to very limited leaching. So you've got this coverage structure and that precipitation that is happening outside during the winter months or a heavy spring rain, that is not happening usually in a high tunnel. And so that affects how nutrients and in the soil stay there or build up. So unless a nutrient is taken up by the crops in that high tunnel, those excess nutrients that remain in the soil can cause issues later on. So that is really one of the basis for soil sampling. And so you can have accurate fertilizer applications, so you're not applying too much or too little to the soil. It helps you better understand your soil fertility. It improves soil management overall. And really, it helps prevent issues later on in the growing season that may lead to nutrient deficiencies in plants or toxicities. And ultimately, this helps save money. And if you think about it, it could help you make money by improving yield. So, soil sampling, there is a correct sampling technique. For vegetable producers and for those growing in a high tunnel, it's really important to collect a new sample at least annually. If you're continually turning over your high tunnel every season and growing new crops in it every season, it would probably be a good idea to sample more than once during the year. For most vegetable crops, you would sample soil from 0 to 6-inch soil depth. You want to sample well before planting. So October and November are a really good time to sample for the following spring. You want to be consistent with your sampling, both in depth and how you're sampling your high tunnel. You want to collect from areas that will be planted. If you are maintaining beds, you wouldn't want to sample in the walkways, for example. And you're going to want to mix your soil sample thoroughly before submitting it to the lab. So what we're going to see is correct sampling technique from beginning to end. The best tool to use for soil sampling is a soil probe, which collects a 1-inch wide soil core. Using the soil probe is helpful because it helps ensure that all the soil core samples that you collect throughout the high tunnel are similar in size. The length of each core should only be 6 to 8 inches, as that is the approximate depth that vegetable roots reach when planted in the soil. Sampling deeper than 6 to 8 inches would not be necessary, and it may skew the results of the soil test. If you don't have a soil probe, you can use a trowel. Make sure that the shovel part of the trowel is at least 6 inches long and try to get an equal size samples as you go throughout the tunnel sampling. You're going to start on one end of the high tunnel and move in an S or W-shaped pattern. Collect cores every 5 to 10 feet, depending on the size of your high tunnel. So if you have a really small high tunnel, your cores might be a little closer together. If you have a big high tunnel, they're going to be further apart. An S or a W shape helps ensure a representative sample is collected throughout the tunnel. And you want to avoid the edges, getting too close to the edges as much as possible. Notice that I'm using a plastic bucket to collect my soil cores. Plastic buckets are recommended over metal buckets to avoid any potential of skewing the results of the soil test. Once you've collected your soil cores, you want to mix them all together thoroughly. Remove any green material or large organic matter pieces. Soil testing labs only need 1 to 2 cups of soil to run all the needed tests. Providing more soil than needed will not help. So you take your mixed sample in that bucket and use that to fill the soil sample bag to the marked line and seal the bag. Now the sample is ready to go to the lab. Make sure it's labeled and that you remember what the label is, or take a picture of it on your phone or write it down. If you have more than one high tunnel, repeat this process for each high tunnel. Do not combine samples across high tunnels. Each high tunnel should have its own sample. Okay, so you have your soil sample and now you need to submit it for testing. You want to be sure to indicate what crop and production system the sample is for. So for the University of Kentucky Regulatory Services, the lab that does our soil testing, there's a spot on there that you can indicate the crop, such as tomato, and the production system, such as high tunnel. And that helps tell both your county agent and me, the specialist, that this is what this is for. So when we look at the soil test results, we can provide the most accurate guidance. It's also going to help the lab give proper recommendations. So there's a basic soil test that you could apply for, and that includes phosphorus, potassium, calcium, magnesium, the soil pH. And then you're going to, because this is a high tunnel, you're going to want to also have soluble salts. That is a separate test that you should request. Nitrogen is not tested, but nitrogen recommendations will be provided after testing. That is because nitrogen can leach readily. It's one of the few nutrients that can reach fairly readily, even in a high tunnel. And so if you tested for nitrogen in November, it may or may not still be there in the spring. It can be mineralized, it can be utilized in other forms, or it can be leached. The other thing that this test will include, if you put that a tomato crop is what you are going to be planting, is a Hartz ratio. So here is an example of a soil test report from the University of Kentucky. The crop is tomatoes and high tunnel, right? And here this person put previous crop was also tomatoes and high tunnel. And here is the soil pH, right? You can see that nitrogen is not included, but there are comments for guidance on how much nitrogen to include for this production system. Phosphorus, you can see it's indicating this is very high. Potassium, calcium, magnesium, zinc, and this Hartz ratio. So if nutrient guidelines for a tomato crop can be found in the Vegetable Production Guide for Commercial Growers through the University of Kentucky Cooperative Extension Service. And here is kind of a breakdown of what you'll find. So phosphorus, we want 31 to 60 pounds per acre of phosphorus. Excess phosphorus, as you saw in that previous soil report, is not advisable, and you will most likely see no yield increase beyond 60 pounds per acre. And in fact, you could see complicating issues if you get up into the 400 pounds per acre. Recommendations for potassium, we would like it to be 200 to 300 pounds per acre, and somewhere in that range. Magnesium, close to 200 pounds per acre. Recommended soil pH is 6.5 to 6.8. To raise the pH, you would apply lime, which should be done 6 months prior to planting to get it to your desired pH. And that is another reason for sampling, soil sampling and testing well before you want to plant. To lower the pH, you would apply sulfur, which also can take a considerable amount of time. Another reason to sample well ahead of time. So if you sampled in October and got your test results back by November, you would have time to apply the lime or apply the sulfur and have it take effect and be able to adjust your pH. It's important that the pH is in the appropriate range for proper nutrient availability. Recommendations for nitrogen. So nitrogen is not tested for on a basic soil test, but we provide guidance. So for a tomato crop, you would apply 50 pounds per acre of nitrogen prior to planting. And then you would follow throughout the season with 30 to 50 pounds of nitrogen post-planting. So for organic growers that have less soluble nitrogen options, you may be applying a little bit more nitrogen prior to planting and less nitrogen after planting. Soluble salts is the other test that is recommended for high tunnel production. We're looking at anions and cations that are soluble in water. And it is really the overall salt content of your soil. So because of that lack of leaching, salts can build up in your soil. And when we say salt, we don't just mean sodium. Contributors could be sodium, magnesium, calcium, potassium, nitrates, chloride, and sulfate. Salts originate from natural weathering of soil minerals, but also can be introduced as fertilizers. Because high tunnels are typically covered with plastic throughout the year, rain is not able to affect the soil as it does in an open field environment. And this leads to nutrients and salts building up near the soil surface or near the crop root zone, which can really be detrimental to crop growth and yield. Here's an example of that. These tomatoes are growing in soil with about 700 pounds of sodium per acre. And these tomato plants are growing in soil with 50 to 80 pounds of sodium per acre. So what has happened here is the grower built a high tunnel, and then they decided to expand, to extend the length of their high tunnel. So the first half of this photo, the lower half of this photo, is the original part of the high tunnel. And so this is after years of fertilizer buildup. Then when he extended it, this soil is essentially fresh, quote unquote, and has not been affected by that lack of leaching and that fertilizer buildup. So these are growing normally and these are stunted. So this is a really extreme example, but a really good way to show how leaching, lack of leaching can really affect vegetable crops, tomatoes specifically. So the soluble salts will show up on a soil test. Here is a table to indicate what is normal and what is high when interpreting your soluble salts test. So really what we want to see is an EC reading of less than 1. When you get up into the 2s and 3s, there may be visible injury on crops and remediation may be needed. So the Hart's ratio, which is something that will also show up on your soil test report, if you indicated that it was a tomato that was the future crop. This is an indication of whether the tomatoes, the future tomatoes, will be at risk for ripening disorders, such as yellow shoulder, blotchy ripening, or white core. Usually these ripening disorders are caused by too low of potassium or lower potassium in relation to magnesium. So here is the Hart's ratio. In this case, it's 0.45, right? So if the ratio is less than 0.35, there is a greater chance that tomatoes will have ripening disorders such as yellow shoulder or blotchy ripening. 0.45, this person should be good, but they should maintain monitoring to ensure that the magnesium and the potassium do not become out of balance. The main points that I'd like people to take away from this are that it's important to soil sample every year, especially for tomato production and especially in high tunnels, as a lot can change in just a few months. Be sure to request a soluble salts test in addition to the basic soil test. Only apply fertilizers needed based off the results of the soil test. And many abiotic issues which can affect yield and marketability with tomatoes can be prevented by following the information gained from the soil test results. There are some resources that may be of interest. If you'd like to learn more about soil salinity in high tunnels, we have a fact sheet for that. UK ID 36, which is the vegetable production guide that I referenced earlier, can be found online. Or for growers in Kentucky, you can get a copy of that at your county extension office. Funding was provided by the USDA Extension Implementation Program.